Okay guys, so this week we're going to piggyback off of last week whenever we were talking about the inside angles of a triangle, and we're going to talk about what is commonly referred to as special right triangles in the math world. Now here's the deal, what makes these triangles special, there's actually two types that are in this notes guide. There's the 45, 45, 90. And there's the 30, 60, 90. Now this is always going to be referring to the angles on the inside. So that's why we need our degree symbol. But these are the two different types. And what makes them special is that they have relationships, their sides relate to each other with a special formula. So for instance, like if I told you, here's a triangle that was 90, but maybe that was 10, and this is 70. There's no relationship between these sides, okay? Even though 70 and 10 are pretty numbers, they don't relate in some magical way, but these two types of triangles do have sides that relate in magical ways. So the first one that we're going to talk about is the 45, 45, 90. And what I'm going to do is draw it out, and then we'll talk about what makes it special. So to draw a 45, 45, 90, I'm just going to draw a right triangle right here. And what you want to do is, if both of these are 45 degrees, something special also happens. We talked about it last week. If there are two angles that match on a triangle, then it means that the sides across from them match. So one of the things that's special about this type of triangle is it makes it an isosceles right triangle. So that's pretty cool. So it's an isosceles triangle. Those two sides match. But the second thing that makes it special is because those two match, we can make a formula to relate all three sides to each other. And what I'm going to do is I'm going to call these sides X, okay? Like this leg right here, I'm going to call this X because I won't know exactly what it is, but I just want to show with a formula how they relate. Now here's the thing, if this leg is X, then this leg must also be X because, well, they're the same length. And the length of the hypotenuse also has a special formula that involves X. Now it's definitely bigger than these other two, but what's cool is it's always bigger than these two by a factor of a square root of 2. So if this was 3 and this was 3, then that would be 3 square roots of 2. And that's just the way that it always works. And just to prove it to you real quick out to the side, if you cared about that, let me do the Pythagorean Theorem on these, okay, because normally we just do Pythagorean Theorem. So let's say that I was trying to find the hypotenuse. So I did this leg plus this leg equals my c squared. Well, if I put those together, that's a 2x squared. And then I would divide both sides by 2. And then I would take the square root of both sides. And when I take the square root of both sides, I get c over the square root of 2. And c over the square root of 2, another way of writing that is, hold on a sec. So I totally got stuck finding the wrong thing. I want you to erase this, please. Sorry, I was trying to solve for x, but we're not trying to solve for x. We're trying to see what our hypotenuse would be. So from this step right here, we would take the square root of this side to make it a normal c, and then we'd take the square root of this side, and the square root of 2x squared is the square root of 2 times x. So I just wrote it flip-flopped, x times root 2, but this is just a proof of why this works. If you don't like it, that's okay. Ignore it, block it out, whatever. It's just showing that this formula always works. So let me show you how you will want to use this, okay? What you're going to use it for is to quickly find the sides of a special triangle. Okay, that's why we're doing this. It's so that we can quickly find the sides and not have to use Pythagorean theorem every single time if we notice those angles, okay? So the first example is going to be find the hypotenuse if you're given a leg. So let's pretend that this is given to you. So take time to kind of draw this out. And you are told that that's 45, and then we're told that that's 2. So if this is a picture that somebody's given to you, if you know that's 90 and you know that's 45, then you should take your own pencil and write in, okay, well that means that's also 45. And if that 2 is the leg, then you would look back up at your picture above, and that picture says x, x, x root 2. Well, in this case, we're looking at this part of the triangle, which is our x, which means if this side is 2, then guess what? That side is also 2. And to get our hypotenuse, we just plug a 2 in the spot of x here as well. So we're just replacing the x's with the number that we see here. Now, if it's a little, like let's say if the picture's turned a different way, let me go back to blue. So the blue will be what's given to you, and the gray will be what we do to the problem. Okay, so if this was given to you, now it's just the picture's turned around upside down, but that's okay. If you were given, let's say you were given that this is the square root of 5. Okay, well, don't wig out. I know you don't like this number because it's not a whole number, but that's okay. We're still going to deal with it. What is this? Is this a leg or is this an hypotenuse? Well, the hypotenuse is always across from the 90. That's the hypotenuse, which means this one's the leg, and on our picture, the legs are labeled with x, which means this is root 5 and this is root 5. Now, what are we supposed to do for the hypotenuse? Well, we're supposed to take our number and multiply it by the square root of 2. In this case, our number is square root of 5, and I need to multiply that by square root of 2. Now, up here, we left that alone because when you have a number like this, you are not allowed to multiply the number out front with the number underneath. If both of these are underneath a radical, it is perfectly legal to multiply them together. So that's probably what your teacher wants to see for an answer, okay? Now we'll go a little bit faster on these, okay? Find the leg if given the hypotenuse. So let's pretend that this is the problem given. You know that's a 45, or they're both 45, and you know that maybe they've given you a 10 here. Okay, actually we'll start easy. Let's start with 10 root 2. Okay, so when you see the picture and you look across and you know that's the hypotenuse, then what you're going to do is you're going to compare this to the picture over here, the picture that we wrote up top. So the 10 root 2 is in the spot of the x root 2. So if we look at it this way and we compare those two numbers, well, x has to be 10. And so that means you can stick a 10 there and a 10 there. So most people can kind of see this pattern, and if they see that, then it's like, oh yay, then 10 must be the other number, and they'll put that on the legs. When it becomes a little trickier, let me turn this upside down for more practice, okay? What if you saw like 11? Instead of the 10 root 2 that we had before. So on this one, it's actually a little bit trickier because what you have to notice is, once again, you have to go, okay, this is the hypotenuse. So you take that hypotenuse and say, well, what part of this picture is it? Okay, well, it's this part of the picture once again. So it is the part that's supposed to match to x root 2. And don't make it too difficult. All that really has to happen here is you're trying to find out what x is, right? You're trying to fill in those legs. So to find out what x is, you do what you always do in algebra. You divide off the number. So whenever I divide both sides by the square root of 2, then I know that my x is 11 over root 2. Now, I'm going to leave the answers like this for the sake of the video and the homework. You will learn from your teachers something called rationalizing the denominator. And actually, if you're coming to tutorials with me, I will also show you how to rationalize the denominator. They won't like this answer because that's not very pretty, and they're going to tell you it's not pretty. It's correct, okay? Technically, this is correct. It's just not the way they're going to want to see it written. But for the sake of this summer, absolutely, you are really good if you can make it that far. And our last example on this page, find the diagonal of a square. Well, if you have a square, I know that looks a bit like a rectangle, but it's supposed to be a square. So draw yourself a square that looks more like a square. Draw a diagonal. And the reason that this stuff pertains is because, remember, on a square, everybody's equal, right? And if these are equal, and you know that there's a corner on a square, it's a 90-degree corner, then look at this. If that's congruent to that, then it has to be the 45, 45, 90 situation. So you might be told, okay, you have a square and the side length is 6 root 3 or something random. Or it could be a decimal, or it could be a fraction. I don't know. But if you know that that's 6 root 3, you know that everybody is 6 root 3. And you're asked to find the diagonal. Well, if you know this relationship from this video, basically from what I just shown you over here, then you know we're looking for the hypotenuse. And if you want to find that hypotenuse, you're going to say, well, this is a leg, and the leg is supposed to equal x. And I need the hypotenuse, and the hypotenuse is supposed to be x root 2. And if that's the case, I need to take my number that equals x and plug it in right there. So I'm going to have 6 root 3 in the place of that x times root 2. And like I said earlier, a normal number is not allowed to be multiplied by these, but since both of these are underneath a radical, you can definitely put those together. And 6 root 6 would be your hypotenuse. So what I want you to do, because this is a long video, there's a lot of information, I want you to stop, and I want you to go to the homework page and look for any of the 45, 45, 90s, okay? And just skim through that homework assignment. Anything that you can tell it's that kind of triangle, use this notes page and try those problems. Then when you're finished with those, come back to part 2 of this video, which will be the 30, 60, 90 triangle. Okay, so if you are clicking on here, I'm going to assume you've maybe tried a few of those other problems. Hopefully it went well for you, and we'll continue on with this video. This is the second kind of triangle that has a special relationship when you do the sides. Now the first thing is the triangle, notice these are no longer the same length because these are not the same angle. So here's my 90, and I need a 30 and a 60. So looking at the picture, this looks like the 30. And this looks like the 60. And another way to think about it is that the short side of the triangle always goes across from the smallest angle. And then the biggest side of the triangle always goes across from the biggest angle, and the medium angle and the medium side. It always relates that way. So you could label it with like a small and a long and a hypotenuse. That's what I normally do. I normally think of this is my short side, this is my long side, and this is my hypotenuse. And so I do S, L, and H usually. And if I don't label it like with my pen in my head, that's what I'm always thinking. So there's a relationship with these, and we're going to use X again, okay? And the formula is the following. The short side you can just call an X, okay? So that's just X. The long side right here is that same number times the square root of 3, and the hypotenuse is always twice as long as the short leg. So notice this is very different from the 45, 45, 90, and it should be because these are not the same length anymore, so it kind of skews all the other stuff up. But there's still a relationship between these three, and it works every time, so it's kind of awesome. So as an example, just to show you with numbers, it would look like this. Like if this was 2, then we could go down to the long side by doing that 2 times the square root of 3. And we could jump over to the hypotenuse by doing this short side times 2. So 2 times 2 is 4. So that right there would be the sides of this triangle. If you wanted to do Pythagorean Theorem to make sure that it worked, feel free to check me. Okay, feel free. A squared plus b squared equals c squared. And if you math that out with Pythagorean theorem, it will work. It will be true, okay? And so, like I said, the point of this is what? It's to be fast at finding the sides of a triangle without having to do the Pythagorean theorem. And by the way, this is all over the SAT. PSAT, SAT, ACT. If you know these triangles, you'll be able to do those problems in half the time. Okay, so here we go. This is like it says on the paper. This is the same idea as before, but now we've got three different sides to find, three distinct sides to find. And my note here of first make sure you know which side is which. This is just to sort of caution you, because sometimes you'll see a picture like this, and it's the picture we drew above, but it's been rotated. Now, sometimes they'll give you an angle, like they'll put the 60 down there, and that's awesome. And so hopefully you'll know that if you see this picture, and if you see this picture, I just want to make sure you understand, okay, with my pencil, I could label, well, that must be 30. So the one across from 30 is the short side, which is x. This is the long leg, or the long side, which makes it x root 3. And this is the hypotenuse, so it's 2x. This is the #1 mistake my students used to make. They would mix up where these formulas went, and then you just don't stand a chance, okay? So this is the most important thing. Make sure you label the formulas in the right spot. Now let's do the next box. Find the hypotenuse given the short side. These are my fave. These are my favorite, because if you see a picture, and let's say this is given to you, 2 root 2, okay. So if they gave me this and they said find the, like in this one, find the hypotenuse, okay? You have to know, okay, well that's the short side because it's across from the 30, which means from our picture over here, the short side is always x. So I would label that as x. And if it wants me to jump to the hypotenuse, remember the relationship is x, and then the hypotenuse is always double that. So I need to double that number or multiply it by 2. So I'm just going to write out that 2, and then my x is 2 root 2. And I want to multiply this if I can. So how do you think we can multiply this? Well, the two normal numbers on the outside, we can multiply those, and then we just need to recopy our root 2 that's behind it. Okay, so that's kind of how you would work through that. So notice it's multiple steps. It's identify the side, label the formulas from above, then plug in and try to figure it out. Okay, so here's another example. Find the long side given the short side. Let's call that one the 30 again. And maybe now it's going to be the square root of 2. Okay. So have they given us the short side? Yes, they have. So what are we going to do? Well, we are going to figure out where the long side is. If this is the short side, this is the hypotenuse, this is the long side, and we need to know the relationships. The short side is x, the hypotenuse is 2x, and the long side is x root 3. So this is just copying those formulas from the given triangle that we did earlier in the notes. And now plug it in. So if x is this number, x is this root 2, then they want me to find the long side, then I just need to take my root 2 and plug it in right here. So what is root 2 times root 3? Well, it is root 6. Okay? So that's how it would work. Okay. Couple more and then you get to finish your homework or try your homework. Okay, so this one is find the short side given the hypotenuse. So if I draw you a picture, now all that we're going to know is the hypotenuse, and hopefully you would be able to, I'll just call that like a 10. Okay, so if you were given this and you were told that one of those was 30 or 60, now let's figure out what we're trying to find, okay? Oh, that's not a 0, that was a 10. There we go. Okay, so the hypotenuse is what's been given. So what you should do is immediately look at your picture above and say, okay, well, what is the hypotenuse supposed to be? Well, it's labeled with a 2x. And what is the short side supposed to be? Well, the short side is over here, and it's just an x. So I need to take my 10 and set it equal to that 2x, because that's how it's labeled above. And then I need to solve for x and get 5, and now you know the short side is 5. And while we're on this kick, how would I then label the long side? I know it didn't ask me up here, but if I wanted the long side, what could I do to take it a step further? Well, if x is 5, this is supposed to be x root 3, so I could just call it 5 root 3. So hopefully this is making sense. If not, that's why we have tutorials. Or you could rewind and try it again, or ask a parent for help if you're not doing tutorials with me. But hopefully it makes sense. Let's try a couple more maybe to clarify. I didn't want to delete all that. Sorry about that, guys. All right, find the short side given the long side. Now I'm just going to erase it all because it looks weird. Okay. Find the short side given the long side. It's hard to tell. See, sometimes it's hard to tell which one is the long and which one is the short side. So that's why it's important to look at your angles. So on this picture, the short side's always across from 30. Maybe they gave me like a 6 here. Okay, so let's pretend all of this is given. What I would do is start with the whole labeling. I'd go, okay, well, here's 30. So across from 30, that's supposed to be an x. The hypotenuse is supposed to be a 2x, and the long leg is supposed to be an x root 3. So you look at what they gave you, which they gave me the 6, and the 6 is written right underneath x root 3. So you need to take those two things and set them equal to each other, since they are in the same spot on the triangle. And I want to find out what x is so I could fill in these other two. So to find x, how do I get that x by itself? I divide off the square root of 3. And those go away, and now my x is 6 over root 3. So where do I stick that number? Well, if x is 6 over root 3, then I know this up here is a straight up 6 over root 3. And if I wanted the hypotenuse, then how would I jump from this side to this side? Well, I would take my x and multiply it by 2. So I would take 6 root 3, or 6 over root 3, and multiply it by 2. And when you do that, guys, just make that a fraction, and then you can do top times top, bottom times bottom. And what we're looking at is 12 over the square root of 3. Okay, last one, and then you are off to your practice. We're going to find all sides based on the picture shown. So I'm going to draw a picture, and this is going to be what's given. And you're going to try to figure out how to work it, okay? Let me do that. Okay, so if this was given to you, feel free to hit pause and try this on your own before you see the steps that I would take. But you want to find all the sides of a triangle like this, okay? So how would I do it, okay? First of all, I would identify what is my short side, my long side, and my hypotenuse. So in this problem, the short would be over here, because short side is always across from the smallest angle. So the short side is the x, the long leg is x root 3, and the hypotenuse is 2x. This is just recopying the formulas that we are going to have to memorize next year. Then I look at what did they give me. So they gave me the square root of 2, but that is sitting right next to the 2x. So since those belong to the same side, I'm going to set them equal to each other. So the math that I would do would be 2x equals root 2. I just set them equal to each other, and now I would try to get the x by itself. Divide by 2, divide by 2. All right, so now if I know that my x is the square root of 2 over 2, then I can come over here and label this side right here as the square root of 2 over 2. So now I know that side. I already know the hypotenuse because they gave it to me. If I need to find that final side, what do? I take my x times the square root of 3. Okay, so I take my x, which is the number I just found, times the square root of 3. Once again, turn that into a fraction by placing it over 1, and then do top times top and bottom times bottom. So it looks like the answer is the square root of 6 over 2. And that would be my answer for the long side of the triangle. Now, go back and finish up that practice, and then on the solutions video, you'll get to check and see if it all worked out. I think it'll be, I hope it all worked out for you. We'll take a look and see how it goes.